Hello everyone. Uh, Again, we will be going with the same topic, that is microprocessor and organization of 8085. In this time, we are going to study about I think block diagram of generic microprocessor. I think we have already seen that microprocessor is actually divided into three parts. That is ALU, registers, and control unit. Okay, I think this we have already studied in the first topic. ALU stands for arithmetic and logic unit, then registers and control unit. Okay, now what we are going to study in this topic is, we have just zoomed this, or we are going in the detail about this. Okay, you can see that we actually have all these three things, but apart from these three things we also have many other things. So this comes for your 4 marks or 3 marks. When you draw the diagram, it comes for 3 marks, but for explanation and drawing it, I think it is going more than 4 marks. So can you see this ALU sections? These all are your registers, and this is your control and timing and control section. So you can say this is an enhanced version of this diagram that you can see on the left hand side. Okay, now we will go in detail. Apart from this, there are many structures. Let me zoom this and just show you. Can you see how the ALU looks? So ALU will be having status register, complement and shifter, adder. Then we have temporary registers, accumulator, HL, then program counter, stack pointer, instruction decoder, instruction register, timing and control unit. Then for transferring the data from one place to another, we require buses. So can you see there are some internal buses we require. This is also a very important thing, that is you can say this is data bus, that is bidirectional 8-bit, and this is your address bus, that is 16-bit. Okay, we will see all the what is A0 to A15 and all in the next coming session. So I hope you understood this much. Now what we'll do, we'll go to the next slide and let's try to understand this diagram. Apart from this, there is a clock, interrupt section, or the blocks. Okay, now just in the previous topic we have seen block diagram of microcomputer. Same way we also have functional block diagram of generic microprocessor. Okay, it consists of the following block: ALU, that is arithmetic logic unit, several registers like instruction register, accumulator, stack pointer, status register, temporary register, data and address register. Then we have program counter, instruction decoder, timing and control section, bus buffer and latches, interrupt controls. So all these things we have to see in this functional block diagram of generic microprocessor. That is very important, generic word. Okay, because we will be seeing one more block diagram, but this time we will be going with generic microprocessor. Okay, now after this we'll go with the next slide. So as you can see, there were many things like ALU. ALU is arithmetic and logic unit, performs arithmetic and logical operations. This unit performs rotate operation. It also affects your status register. I think status register will come to will go in detail. That is also known as flag. Okay, the results of ALU are placed in the accumulator. Most of the time the results or whatever the output comes, that is stored in the accumulator. That is very important. Then several registers, as we were talking about, one of them is accumulator. It is a 8-bit register used to store the 8-bit data. The result of ALU are placed in the accumulator, as you can already see. So this is a very important register. Then we have instruction register. It is a 8-bit register. The first byte of the instruction is stored. Okay, whatever the instruction you want to give to the microprocessor, that is actually stored here. Then we have status register. It is also called as flag. This is also very important because status registers are also known as flag. Okay, Um, when we go about 8085, there are many flags, but right now you can see there are less number of flags, which consist of flip-flops that are set or reset according to the data conditions in the accumulator. The generic microprocessor has only two flags, that is 0 and carry. Uh, 0 flag, that means if all the 8 bits are 0, and carry flag means if the ninth bit is generated. Flags we will see in detail. Okay, right now you can in generic microprocessor we have only two flags. Now program counter is very important register, because it is a 16-bit register containing the address of the next executable instruction. It can it can be incremented or reset by the control section. So remember that as the name indicates, program counter. Program counter means it will always store the address of the next instruction to be executed. Okay, whenever we do the programming, we keep all the instructions in sequence or anyhow, but which instruction to be given next, its address is stored by the program counter. So it's a very important link to execute your program. Now we have stack pointer also. Stack is a temporary memory. So it is a 16-bit register consisting of address of memory location called stack. Stack is a read-write memory for temporary storage. So you can read, you can write in this. Then we have data address register. Okay, so it is like multi-purpose. Okay, or you can use the same registers for data and same registers for address. Okay, or you can say maximum utilization of register, because we have very less number of registers. Okay, it is a two 8-bit registers that can be used separately or as well as in combined pair. They are labeled as HL, H and L. Data is stored in these registers. When used in pair, 16-bit addresses are also stored. Okay, so you can say that this is, I think in the diagram you might have seen H and L or address data registers is stored. Okay, now we'll go with the next. I think these are all instructions, that is instruction decoder. This interprets the contents of instruction registers. I think just now we have seen the instruction register, which will tell you what it will just tell you what is the instruction, but it will not able to decode, because it has to be understood by your microprocessor, then it has to be given for the execution. That work is actually done by the instruction decoder and determines exact steps. See, I think it interprets. Okay, if the microprocessor don't understand, so it will interpret, and it will also determine the exact number of steps in followed in the executing the entire instruction. So everything it directs, okay, to the control section. Okay, it directs the control section accordingly. So all the decision taken by the control section actually told by the instruction decoder. So whatever the instruction decoder is telling to the control unit, so control unit will take the decision according to that. Now let's come to the very important part, that is timing and control unit. This section receives the signals from the instruction decoder. Just now you can see from the about topic to decode, to determine the nature of the instruction to be executed. So it decodes everything from the instruction decoder, then it thinks how to execute, what which registers to be taken into account for execution and all. Timing and controls signals are sent to the parts of the microprocessor. So it will take the decision, it will tell, and it will just send all the important things to other parts of the microprocessor. I hope you understood. Now there are two very important buses, that is address bus and the data bus. I think in the previous session also we have seen address bus. The address bus is a group of 16 lines or wires identified from A0 to A15. It is unidirectional, that is only in one direction. Bits flow one direction from microprocessor unit to the peripheral devices. Then we have data bus. data bus is used to is a group of 8 lines. It is not of 16, it is of 8 bits used to data flow. It is a bidirectional. So I hope you understood the very important difference. This is your unidirectional, this is bidirectional. That is data flow in both the direction between the MPU, memory and peripherals. Okay, microprocessor unit to peripherals or peripheral to memory or vice versa. Okay, so I hope you understood till here. Then we have bus buffers and latches. So latch is a flip-flop used to store one bit of information. Um, so you can say it is like a flip-flop, or whether it is on or off. So on means that will store the information, off means it will not store the information. So information is stored into the latch by enabling the buffers. So I think this is the explanation of your 8, you can say the generic functional block diagram of generic microprocessor. So these were the all the registers or the blocks and all. So bus buffers, I think interrupt control is remaining, that we will see when we'll cover about the interrupts of 8085. Okay, so I hope you understood everything till here. We'll meet in the next section. Thank you.